So as you can see here on the board, we have written here over there circle. Circle, we are not going to learn the circle basic terminology, because in the earlier classes we know what is the basic terminology that is related to the circles. Now we can say that we will just have a review of that. If this is a circle, then that point from which each point over the circle is equidistant is known as center, and the distance between the perimeter and the center is known as radius. That line segment, we can say, or the chord that passes through the center, that chord is known as diameter, and the chords that are not passing through the center are simply chords. So diameter is the longest chord that we learned that. And now if a line passes through the circle, that is known as secant. That is known as secant. Okay. So now today we will learn about tangent. Now what is tangent? If this is a circle, as we can see the definition, a tangent to a circle is a line that intersects a circle at only one point. Means that line, if it is one point and passes through one point only, that is known as tangent. Or we can say that if it is at one point, there is only one tangent pass. At one point, only one tangent can pass. This is the property of tangent, and later one by one we will learn about all the properties of tangent. Okay, so here I am writing some important point. First we will discuss those points or important facts about the tangent to a circle, and then we will move towards few examples that will help you to solve the exercise related to tangent to a circle. As we can say, there are 5 points. So one by one I will discuss all the points, because these points are very much important before we solve the exercise. Okay. So first is the definition only. A tangent to a circle is a line that intersects the circle at only one point. Always remember, secant intersects the circle or the perimeter of the circle at 2 points, whereas tangent intersected at 1 point. We can see that if this is a circle and we are drawing several parallel secants, then we will see there is a one secant is outside the circle and that touch exactly at only 1 point. So this line which touch the circle outside it is known as tangent. It exactly touch at 1 point, and at 1 point only one tangent can be drawn. That is also one of the activity in your class. We will discuss that also. So if it is a circle and at 1 point we are drawing different, so we will different line segments through that points. We will see that there is only one line that passes through that point, exactly 1 point, and touch at 1 point. Okay. Now we can say in another line, as I explained here, that tangent to a circle is a special case of secant. But these are the factual, these are the facts related to the tangent to a circle, and these will help us to crack the MCQs or 1 mark questions. Okay. Now there is a no tangent to a circle passing through a point lying inside the circle. Obviously, if a point lying here, the tangent can't be passes here, because at least it will touch it at 2 points. So from inside also and from this point also, these two are not tangent. Tangent is that the point lying on the circle. So next point here is it. There is a one and only one tangent to a circle passing through a point lying on the circle. Means if the point is inside, no tangent can be drawn. If the point is outside, no one tangent can be drawn. Why I said one, I will explain you. But if a point lying on the circle, then one and only one tangent can be drawn at that point. Now students, you can see here, there are 2 points I have written. Actually, these are not the points. These are the theorems of the circle chapter. Okay. So first one is the tangent at any point of a circle is perpendicular to the radius through the point of contact. Now what is point of contact? We will see here. So if this tangent touch the circle at point A, then this point is known as point of contact, and the radius is always perpendicular to the tangent through point of contact. So point of contact पे ये क्या है? That is perpendicular, 90 degree. So we can see one sum. The question can be like if it is O and it is P. So the question can be asked, write the value of angle AOP plus angle APO. Now it will come in 1 mark. They can give you that OA is the radius and AP is the tangent. Then find the value of angle AOP plus angle APU. So students, we can simply see here that if we know that the sum of 3 angles of a triangle, this is one of the application beta. One of the example of this application of this theorem I am explaining. Okay, I will tell you one more thing also. Now, so here one angle is of 90 degree. So we know that the sum of 3 angles of a triangle is 180 degree. So these 2 angles sum up 90 degree. Obviously, when these 2 are 90 and this one is 90, the whole 3 angles will be of 180. Similarly, they can give you the value of this and value of this one. So maybe you have to find this value. Okay, beta? So the thing is, the question can be asked, if the radius is 3 and the AP length is 4, then what will be the length of the external point from the center of the circle? So here, since it is 90 degree, we can use the Pythagoras theorem also. So it depends upon कि आप sum को कैसे solve करते हैं. These are the application one by one through the example we will learn about that. Okay. Now the second one. Second one is the length of the tangent drawn from an external point to a circle are equal. Now we can see here, this is a circle, and from a point P, these are 2 tangents. So from an external point, if we draw 2 tangents, these 2 tangents will be equal in length. Okay, will be equal in length. One application we can see here. Here you can see it's a one triangle and the circle is inscribed inside it. Okay, and the length is given. This one is 3, this one is 4, and this whole length is 8 centimeter. So we have to find the value of BC. So here we will use the application of this theorem. We will check if we see closely, we divide the diagram, then we can see that AM and AM are 2 tangents drawn from point A. And we know that from external point, if we draw 2 triangles, they are equal in length. So these 2 will equal in length. If this one is 3, this one is also 3. The whole line is 8 centimeter. So if the whole one is 8 centimeter and this part is 3, then this part is 5 centimeter. Now, BL and BL are 2 tangents drawn from point B. So it will be 4. Now, CM and CL are 2 tangents drawn from C point. If it is 5. So the length of BC is 9 centimeters. So these are the applications. Now student, one more question. We will learn this topic with the help of examples. So 2 concentric circles of radius 5 centimeter and 3 centimeter. Okay, and find the length of the chord of larger circle which touches the smaller circle. So here first we will draw the diagram. We can make it. 3 centimeter, and this complete is 5 centimeter. Okay. So now students, we will see this was the diagram, and what we have to find the length of this complete chord. That is the chord of the larger circle and which touch the small circle. So now here two radius are there, so we can draw it the figure here like this. This is the smaller circle, this is the larger circle. Now see this diagram. This was the diagram just to explain you. But after looking at this diagram, you people might say, "Kilo, ये तो बहुत ही आसान था." Yes, and this is really very simple. So here, this is the radius of the smaller one, and this one is the radius of the larger one. Let O be the center. We will write here. Let O be the center of both the circle, and AB be the chord which touch it at L point. So students, if we see this chord touch smaller circle at one point, it means that AB is a tangent to smaller circle. So now we can check here if this is a tangent and this one is radius, so that at a point of contact the angle will be of 90 degree. If the angle will be of 90 degree, now we can see that by triangle OAL, Pythagoras theorem. From triangle OAL by Pythagoras theorem, now we know that if this is a hypotenuse, this one is a base, so now we can do that. 3 square plus AL square equal to 5 square. 9 plus AL square equal to 25. So AL square equal to 25 minus 9. So here we will get AL square equal to 16, AL equal to plus minus 4. We can write, but the length can't be negative, so we will take plus 4. So, and also we know that radius bisect the chord. This we know that. If radius is perpendicular to the chord, it will bisect the chord. This is in your previous classes, we will learn this. We have learned this concept. So if AL is equal to 4, then AB is equal to AL into 2, 4 into 2, 8 centimeter. So have you see? So here is the second example, that is in the form of a sort of theorem that proves that the parallelogram circumscribing a circle is a rhombus. So here we will check it accordingly. We will first assume, we will draw one parallelogram and a circle inside it. Let ABCD is a given parallelogram that circumscribes the circle, and that circle touch the AB, BC, CD and DA at P, Q, R, S respectively. Okay. So after that proof, we know that in given, we should always go by that, the given, the construction is there. And then in proof, we know that the lengths of the two tangents drawn from external point are equal. So here if we can see, we can check it. AP equal to AS. So here AP equal to AS, BB equal to BQ, CR equal to CQ, and then DR is equal to DS. So these are the sides. So now we will check how it will work, like how we are going to solve with the help of this information. We can first add AB plus CD, these opposite. Okay, so if we add them AB and BC, or we can check here, then AB is equal to AP plus PD, and then this one is equal to CR plus DR. CR plus DR. AB and CD, AP plus PB plus CR plus DR. Okay, why? From these part, like if it is AB, then AP plus PB, and if it is BC or CD, then CR plus DR. But from equation 1, 2, 3, 4, we know that AP is equal to AS, BP is equal to BQ. We will put that values. If we substitute those values, now we take those values AS plus DS and BQ plus CQ. So now we can check it, AS plus DS, BQ plus CQ. When we add them, we will get BC plus DA. Means AB plus CD is equal to DA plus BC or BC plus AB. But student, we also know one of the property of parallelogram, that in a parallelogram opposite sides are equal. Means AB is equal to CD and BC is equal to DA. So if we substitute that value, AB plus AB and DA plus DA or BC plus BC. So we will get AB equal to BC. Means these two sides will be equal. So these are two adjacent sides, students. And we can similarly prove this AB is equal to DA also. If we put here DA in this part also. So similarly, all the four sides will be equal and this parallelogram will be rhombus. So we will see more examples in other video. Till then, you can watch this video and see like how the problems you will deal it. Thank you.